All right, hey guys, JMO here. We're going to be doing part 8 today. A few things different with this part, you can already tell. We're just doing an ISO view, and we're going to talk about this drawing real fast, and we're going to talk about why it's different, and then we're going to build it. Some new tools to add to the belt as well today, 3D sketches, extruding, or extrude cutting 3D sketches, but you've probably noticed by now, extrude cutting and extruding material is essentially the same principle, just in reverse. So once you have this sketch and you know what and where you're extruding or extrude cutting, it's pretty self-explanatory. So we're gonna build this part here. As you can tell, it's just an ISO. You'll see this a lot in the book. So if you're used to an image like this, cool. If not, this is why I'm showing you this, is because this is pretty typical. They'll give you all the dimensions you need in one image, and you just have to kind of know how to build it. They'll often give you variables too. These are called global variables in the system. And you can edit these and add them, and you can go through a bunch of different versions of them. Typically it's A, B, and C. So they give you like length, width, and then height, and or maybe like a diameter of a hole. And the reason for this is, again, you're studying for your CSWA, you're trying to pass it. They give you that testing module. If you've seen it or not, you can go get a free testing module and do the free sample exam once a month from SolidWorks website. So go do that if you haven't. It's good to see what you're looking at and know what you need to do before you even do it. I highly suggest taking that sample exam. Maybe we'll do a covered sample exam in one of these videos soon. Who knows? But regardless, like I've mentioned before, you'll get one part. They'll give you all the dimensions. They'll have you enter A, B, C, or D for the mass. So you build the part, you check your mass, you see if it matches any of the ones on the A, B, C, or D, click it, go forward. That second part, you edit again, and then you enter in the mass properties like physically with the number key, and you put in down to double decimal. So with that thought process, right, you have to edit a sketch or a part you've already worked on that have these global variables. Say it had like 4 holes in the part, and the hole was one of the variables. Do you want to go into each sketch that had a hole and change that number? Or do you want to go click one time in your global variables and change one number one time and have it affect all holes? So that's what we want to do, because it saves time and it's smarter. With something like this, it's not too crazy useful, because again, it's just length, width, and height. So say you did need to change any one of those, you're only working in the sketch for length and width or height, and then the extrude for the last variable. So you really would just right click, edit, change the one variable, and it would fix it. But you can do the same thing here in equations and global variables. Cool. So just know that it's useful most of the time, not all the time. My teacher didn't even teach it to us. But when I learned about it, I started implementing it, and I found it greatly increased my speed. So that's what we're talking about today. And then the last thing we're going to touch on is this weird triangle cut out of this square box. There's not a lot of easy ways to do this. We've talked about it before. You can make a sketch, and you can make another sketch, and you can extrude cut that sketch along the sketch that you have drawn to be your path. That's a little more work than we want to do. So we're going to work in 3D sketches, and we're going to extrude cut this part in a 3D sketch, and you'll see how that works. All right, I think that is everything. Oh, last thing. Sorry, I want to touch on this. This is the first time we're seeing this symbol, 25 millimeter depth or deep. If you double click on any of these, it brings up the dimension information, and you can add dimension information. So I just use the depth deep one, so you know how deep this hole goes. So self-explanatory. Cool. You've seen new drawing stuff. Let's go into our part. New part. First things first, as always, let's put it in millimeters. We know our sketch from looking at it, hope you guys are paying attention, was on the front plane. We're going to pause right here because we need to add in our variables, right? That's what we talked about. You probably don't have equations and materials here. You can right-click, hide show tree items, and show those tree items there. Make sure to do that because you're going to want these over here. Right-click, manage equations. Global variable A, I believe, was equal to 100. Global variable B was, I believe, equal to 75. And these are in millimeters. It's going to be in the dimension or measurement that you first initiated. Okay, all those are in. Let's double check which is which on our thing. Exit the sketch so we can jump around here. Let's close this. Here. Okay. Excuse me. Okay, since we're sketching on our front plane, we have A and C as our height and length, and then B will be our extrude distance. So let's make sure to remember that. We, in other cases, might have drawn out this side profile, ignoring this triangle cut, and done like a long L, a weirdly long-bottomed L. But you'll see that would not allow us to use our C very easily. We'd have to like use C one time and then cut down the next, and it's a little less worth it when you are skilled at extrude cutting like we are now, right? So let's do this. We'll see how much faster this can be by center point triangle. We know this one to be C, so we're gonna go equals quotation C, and that has to be capital. Didn't get the quotation finished. Boom. We know this one to be 100, so this one was A. Cool. And then we know the extrude depth to be mid-plane, and we know that one to be equal to the only variable we didn't use yet, B. Cool. So let's check our ISO, double check, make sure all the proportions are in shape. It is. Okay. So now let's look at this 3D sketch. Like I mentioned, we could have drawn an L, and then we could have 3D sketched into here. But we could easily just do this, grab this. We know this. Let's do a corner. We know this to be the whole length of it. So this one was definitely 75. And proportionality speaking, we knew it was somewhere over here. So it's probably 75, a box. Let's just double check that look though. It doesn't say, but check this out. 12.5 to the center of this, 12.5 twice would be 25. So that, I think I've mentioned it before. You can make assumptions. You can make assumptions, yes. But you should definitely always double check that those assumptions are valid. Don't just make an assumption and then roll with it, because that will bite you in the butt later on. It will bite you. So don't do that. And you've probably heard me say you can make an assumption, but you'll probably also see me go and double check that assumption almost instantly to make sure that I am on par. That doesn't look right. I put 25 there. That doesn't look right. 15. That's why. So let's go back and let's edit this cut extrude. Let's just change it. Cool, 15. Our first 3D sketch now. We have our general shape. And you're going to see this. This is kind of interesting because sketching normally requires you to click on a plane or a surface to sketch on, right? 3D sketching does not, because you're sketching in 3 dimensions. So you hit 3D sketch and you're already sketching. You didn't have to pick anything. Let's use our line tool. We know it was going from this corner to this bottom corner to this top corner, because it's all just kind of relation. We didn't even need measurements. We can see it based on how it was related, right? Click, click, click. Now, if there was any distance here, they would show that distance in a measurement. There'd be a reason for it. But since you're not seeing it, we have it. And now we do our cut extrude. We can click on a face to have this cut extrude too. And you can see it's kind of leaving out that chunk. If we just do through all, or even up to next, I believe, that'll work out beautifully. Yeah, look at that. Cool, so we are 80% done. Let's do that last cut. We know how to sketch on a random surface. Let's sketch on this surface. Let's grab a circle. It looked in relation to the origin here, and we know it to be 12.5, so let's do that. I think it was radius 5. So if we do 5 here, I think it's going to go diameter. So let's do 2.5. Yes. Oh, yeah, I did 2.5 diameter, so we needed 5. 10? That's how math works. We know this to be in relation to the origin horizontally. And I believe they actually gave the distance on that. Yeah, 37.5 and 12.5. So it did center it in that little spot there, which is nice. It's good math for us because we can just kind of tell that it's centered. Good. Good, good, good. Okay, so now we're just going to extrude cut deep, and we know to go blind, and I believe that distance was 25. Cool. Not all the way through, and that's why it gave you that depth. If it was all the way through, it probably gave you the all the way through image or counterbore with a depth that was the exact depth of the item itself. Okay, I think that's everything for this part. Let's double check our ISO, and then let's double check our origin. And then, like we've talked about, we're going to put the mass properties in the description. I think the only thing we haven't done is changed our material to brass. Yeah, we haven't. Material brass there. But everything looks great. That looks great. Add material. And again, I don't like to skip through those. I like to type at the top. It's much faster. Sorry, I'm a little sniffly, fighting a cold. All right, our part is done. And let's really quick, just refresher. If we right click and manage equations, we can change A to be 200. Not 1200, that's way too big. Let's do that real fast and see what happens. Whoa, crazy. So exactly like we mentioned, and all of our relations are kept in, right? Let's look at our sketch over here. Since we said 12.5 from this edge, it kept it 12.5 from this edge and only distanced it. And that's why we like to fully dimension things within SolidWorks, because as you edit variables and make different decisions on how the part should look in the end, or based on maybe you did some testing with stress analysis or airflow or water flow, and you realize, oh, I don't have enough volume coming through this component. Well, now you can just go and change your variable a few times, run the simulation, cut out a couple different packets explaining the differences in distances, of volume going through, and you can optimize very easily using this type of thing. Instead of going in and editing your sketch, you now see how that can play in. All right. I actually controlled Z out of brass. Let's put that back in there, and then we can end this video. Appreciate it, guys. If you guys have any questions, just go ahead and ask. I think we're just going to keep chugging along. Thanks, guys. We'll see you for part 9.